Okay, so this is a lab that I have not always done, but it's an option for the work and power portion of the curriculum. Um, anyway, exactly how you get it raised up is up to you, but you'll need to raise one end of this ramp, and possibly that could be using a stack of textbooks. Alternatively, you could, like I mentioned in a previous video, you could get those metal poles and you could set those up in these spots here with a crossbar, and then you'd be able to move the crossbar up and down the poles. If you can picture two metal poles here, bink, and then a crossbar between them, you'd be able to raise that or lower it in order to raise or lower this ramp. Okay? In any case, however you get that done, it's up to you. Then you have to put on the force probe like we did in a previous video. Though for this one you would need the hook attachment instead of the bumper attachment. To keep this video short, I'm not going to replace that, but here's the hook attachment, and it would just go in place of that guy right there. Okay? So, sorry for the troubles with focusing here in the video. So yeah, that would be there. There would be a hook on the force probe, and then you would need to loop a string over the hook, put the other end of the string through the back of this pulley, and then you would pull upwards, and then this thing would translate, like basically this thing would tell you what the force is that you're pulling with. And then you would pull that up the ramp some specific distance, and then you could use force times distance to find the work that was done, and then you could compare that to the increase in gravitational potential energy. So if you can tell where the cart was at the bottom of the track before you started pulling it, then it's at some height above the ground, and then find out how far it is above the ground when it gets to the top here. Find out the linear distance, right? The linear distance of that, and there's actually like centimeter markings all along the track, so you can just use those centimeter markings to find out how far the cart moved up the track, multiply by the force you were applying, maybe average the force over the time that you were applying it. So force times distance tells you how much work you did in raising that cart, and then you could compare that to the height difference of the cart from there to here, and using the gravitational potential energy equation, you can find out how much gravitational potential energy it gained, and then compare that to the work that was done in moving the cart. So it's a reasonably decent lab. Doesn't take all that long to accomplish, but takes a while to set up. I'm not gonna, again, in the interest of having at least one short video, I'm not going to go into all the details of how exactly you raise and lower this thing. You could just use textbooks. You could use bars, 2 vertical bars with a crossbar that you could raise and lower. And that would be about it for that lab.